Hey everyone, this is Mr. Ernest, and I'm doing 2.1 to 2.4 practice sheet. You may have already done this quiz, and that's cool, but you can always go back and do it again if any of this stuff you didn't understand, and maybe this helps, I don't know. Yes, these are crushed tomatoes. Found this hack on the internet, you know how it is. All right, number one. So we have a function using this f of x notation, and it is x squared minus 3. Now it wants to know what f of x minus 4 is. So the thing you do when you evaluate is you replace x with whatever is in the parentheses. So this becomes x minus 4 squared in parentheses with the minus 3 still attached. So what this is a binomial squared, and you have to go back and think about what that means. If you write it twice and then FOIL, that'll get you there. Like so. So we FOIL, we get x squared minus 4x plus 16. And then that is minus 3 is still there. And then we combine like terms. These two, is x squared, minus 8x. And then these two, 16 minus 3 is 13. All done, right? So most of the evaluate problems are asking you to plug in a number. This one's weird because it asks you to plug in x minus 4, which has a letter in it. No big deal. We just remember what we learned for polynomials. This one asks you to put in a number, so it's not quite as bad. Not quite as work intensive, I guess I should say. But it wants f of negative 2 when f of x is the square root of x plus 6. So it's the same thing, square root of negative 2 plus 6 instead of x. And inside the square root, we get 4, and the square root of 4 is 2. And that's the answer. Okay? Well, that's evaluating. Moving on. The graph, you don't have to worry about the graphs. I didn't know how to put graphs in the quiz, so, I guess don't worry about that. But if you're looking at number 3 on this worksheet, and number 4, it asks you for the domain and range. And the domain and range are all about, and I can use this, they're all about what the graph does left and right for the domain and what the graph does up and down for the range. So in this case, this goes all the way left, all the way right if you keep going. So it's all real numbers for the domain. And then it goes all the way up, but it doesn't go any farther past negative 2 going down. So the range would be negative 2 to infinity, just so you know. This one, the domain is all real numbers. And the range goes from negative infinity up to 3, which is the highest point along the up and down on that graph. This one, the domain starts at 0 on the x-axis and goes off towards infinity. And the range starts at 2 and goes up towards infinity. So the domain is 0, infinity, range is 2, infinity. Whereas the function increasing is like if you're reading this left to right like it was a book, like a sentence in a book. So you're going left to right, it's going down, 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 down until it gets here, and it starts going up, 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 up. So really right here is where it starts increasing. And we're talking about x values again, left, right, just like domain. So it looks like it's starting around 3, and then it's going off towards infinity. So that's where I would say this is increasing, 3, infinity. With this one, when it's decreasing, again, left to right, it's going up, 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 and then it gets here and it starts going down, 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 and that's the part I want. So along the x-axis, again, it looks like it's about 5. It's not quite 6. So starting around 5 and going down to 12 along the x-axis, that's what I would put as my answer for number 7, 5, 12, right? So left to right, going down, you just want the x values. Symmetry, you have to, this is definitions, so if it reflects about the y-axis like it does here, like if you fold this like a piece of paper at the y-axis, it would be the exact same graph on both sides. So this is even. Even Steven. This one, if you fold along the y-axis, it won't match up. This guy will end up over here, this guy will end up over here, so it's not even. But it is odd because if you were to rotate this, if you were to rotate it around like 180 degrees, halfway around, it would be the same graph. Another way to think about that is if you were to flip it along the y-axis and then flip it along the x-axis. Is it the same graph? Yes, so it's odd. All right, back to this. Piecewise defined function. Let me try to get it set back up without falling. It's a tenuous little thing I've created. Oh. Pull that back. Okay. So number 10, this is something that you might see, a piecewise defined function. And what a piecewise defined function is just two functions that are kind of slapped together. So the first function is this one, x squared plus 5 over x plus 8. It's a rational function, which is something we would have talked about in intermediate algebra, but it's basically a fraction. And this one is x minus 1, which is just a line. And we're going to talk about that more later on in this practice sheet. Now, they can't share the same space. Like, two graphs can't be in the same place at the same time. So we split up the domain, the x-axis. And then what we're doing here is it says if x is not equal to negative 8. So basically what that says is that for every x, it's this guy, except for him. He's the only one that you do not apply this function to. So this is the dominant function. He's all over the place, except for one place, and that's negative 8. And then this bottom one is only if you have negative 8 as your x number. Okay? So this guy is only brought in as a backup whenever x is negative 8. Otherwise, it's this fraction that you're dealing with. So forget about him if it's not negative 8, and forget about the fraction if it is negative 8. I don't know if that makes sense, but I'm hoping it does. So what they really ask you here is evaluate. Once again, we're plugging in a number, but we have a choice. Do we plug it into the top one, or do we plug it into the bottom one? Put a double underline. And that depends on what it is. Is it negative 8 or is it not? It's not. So we plug it into the top one, the dominant guy. Forget x minus 1. We don't care about him anymore. All right, so we plug it in 5, and we get 5 squared plus 5 is 30. 5 plus 8 is 13, and that's the answer. So yeah, so 3 evaluate problems. I'll ask you to plug in a number, but this one is the one where you have a choice, and you got to make the right choice based on what it says after the if word. Okay. Find the slope. That is a formula, and that formula is m equal to y2 minus y1 over x2 minus x1. It's a formula that I'm pretty sure most of you are familiar with from high school. I can't remember if I talked about this before the break or not, and I'm just going to pretend like I didn't. All right, so with number 11, we're given 2 points, 2 comma negative 3 and negative 7 comma 8. And we have to label this x1, y1, x2, y2, x1, y1, x2, y2, and that will help us know where we're plugging in, what we're replacing these letters with. So y2 is first, he's over here, he's 8, minus. y1 is negative 3, so we got a minus minus situation going on. x2 is negative 7, minus x1, which is 2. All right. Just replacing numbers, letters with numbers. So the minus minus becomes plus, and that's 11. These two are the same sign, so we add, and that's negative 9. And there's nothing else to do. That's the slope. Let's do another. Same formula. 5 comma negative 7, negative 8 comma negative 2. So again, I like to label x1, y1, x2, y2. So the slope becomes y2, which is negative 2, minus y1, which is negative 7. Again, minus minus going on. x2 is negative 8, minus x1 is 5. So minus minus becomes plus. They're different signs now. This is positive, this is negative, so we're subtracting, keeping the larger numbers sign. Positive. And then these two are the same sign, just like over here. So that becomes negative 13 because we add, and that's all done. All right? So finding the slope, not too bad, right? Number 13, that was number 12, is a trick. trick question. Let me write it out for you first. -8, -9, -8, -3. Label x1, y1. Maybe I don't see the trick yet. x2, y2. And I use my slope formula. y2 is -3 minus y1 is -9. Seen that before. -8 is x2 minus -8. Okay, so we got two minuses going on here. They become plus. And so we subtract, different signs subtract, we get 6. Different signs subtract, we get 0. Now that's a problem. 0 in the denominator is a problem. If 0 had been in the top, we'd be fine. The answer would be 0. But because 0 is in the bottom, it is undefined. It is no good. We don't like it. We don't have a defined slope. And there's a certain type of line that has that kind of slope. It's the vertical line. Yes, I'm drinking coffee. What? All right. Moving on. We have number 14. Let me bring this down. Here we go. And it is asking you to write an equation in point-slope form. Now, point-slope form is also a formula you have to remember. Y minus y1, or do you have to remember it? Oh, dear. Online classes, right? Anyway, so we got y minus y1 equal to m x minus x1 in parentheses. And this is point-slope, PS. The other type of line equation is y equal to mx plus b, which is something you're probably more familiar with. That's the slope-intercept form. So using this form is what they ask for in number 14. Your slope, m, is 5/6, and your point is 3, 5. Now this is x1, y1. So when we use this formula, we're going to just plug in numbers for these letters. y1 is 5. Slope is 5/6. x1 is, x minus x1 is 3. And you're done. That's all I want. Point slope form. Nice, huh? That wasn't nearly as work intensive as you thought it might have been. The next one, they only give you 2 points. So -4, -4, and -2, -7. Now the two things you need are slope and a point. Well, they gave you an abundance of points if all you need is 1, but they didn't give you the slope. You need that. So you need to use the old slope formula to figure it out. So let's label x1, y1, x2, y2. -7 is y2, minus -4 is y1. -2 is x2, minus -4 is x1. Minus minuses become plus. Different signs means we subtract. Larger number keeps the sign. Different signs means we subtract. Larger number is positive. So we get -3/2 is the slope. And here's x1, y1 already labeled for us. So all I really need is this guy and this guy to put my equation together. Y minus -4, that's my y1. Slope is -3/2. X minus -4, which is my x1. So we end up getting y plus 4, and then -3/2 times x plus 4 as the final answer in point slope form. Now in number 16 and 17, they ask you to do it in slope-intercept form. So the reason why we teach point slope form first is because it's way more likely they'll give you a slope and a point or 2 points. And then you'll have to write the equation like this. But to get the slope-intercept form, all you need to do is distribute the slope into this parentheses and then do the opposite here to get y all by himself. Because look, it's y equals a bunch of stuff. That's the slope-intercept form. So with number 16, they give you 2 points, just like number 15. So the process is this, doing all this, finding the slope, putting it in point slope form. But then you have to do a little extra. So let's see how that is. Slope, label, x1, y1, x2, y2. We get 6 minus 3 over 4 minus 5, just following the formula. And we get 3 over -1, which, you can make the -3 in a whole number. Okay, point slope form, we get y minus y1, which is 3. Slope is negative 3. And then x minus 5. Distribute. This is the extra work. We get negative 3x plus 15, because two negatives make a positive. And then you are going to do the opposite to this minus 3. You're going to add 3 to both sides. And you'll end up with y equal to negative 3x plus 18. Ooh, I was barely in frame. Okay, here you go. What's that slope-intercept form? So it's just like point-slope form problems. You find the slope first, then you use the point-slope formula, but then you do a little extra to get to the slope-intercept. Number 17, they give you the slope. Oh, that's nice. And, ooh, they give you the y-intercept. So the y-intercept is 2. That, as a point, is written like 0, 2, just in case you want that point. Now, the good news is you can just do this same process with these two numbers. You don't have to find the slope now. They gave that to you. So you're really just starting here and going down. Or if you realize that we have the slope-intercept form, all they need is the slope, and this is the y-intercept. Well, that's what they gave you. So you can just use that formula, slope 4/7 x plus 2, and you're done. It's that quick. That was one of those questions that I put on there so that you could, show off what you know, I guess. But you don't have to do it this way. You can do it this way, and it'd be fine. Coffee. All right, graphing the line, we're going to skip that because, well, we can't really graph. And that's okay. So that skips a bunch of questions on here. But that's okay because we got, a lot of this stuff done that matters, like how do you find the slope? How do you write the equation of a line? Those things are big in college algebra. Graphing the line, is just finding points and then drawing a line through them, right? No big deal. Number 24 is the next time it doesn't have a graph, and it asks you determine the slope and the y-intercept. So let's look at that. So we have 10x plus y plus 9 equal to 0. Now this is what's called a general form, and that means that everything's on one side. So what we want to do is we want to get it to look like the slope-intercept form, because if we did, then we could tell you what the slope and the y-intercept is. The slope-intercept form has y all by himself, and so these dudes are crowding his side. We got to do the opposite to get him over there. So minus 10x minus 9. And we got to do a minus 10x and a minus 9 over here. Because remember, whatever we do to one side of the equation, we do to the other. So that'll get rid of him and him, and we got y by himself. 0 doesn't do anything, so we're just going to write negative 10x minus 9. And now it's in slope-intercept form. Hey, how about that? Slope is negative 10. The y-intercept is negative 9. Zoop, zoop. That's what they want. So like number 25, same deal, with an extra step. We got negative x plus 6y minus 42 equal to 0. And what I would do is I would try to get y all by himself. So I'm going to do the opposite. I'm going to say plus x, and I'm going to say plus 42 to these other bums. Get them over here, right? And boom, they're gone. All you're left with is 6y. And then over here you got x plus 42, because again, 0 doesn't do nothing. All right, now we got to divide by 6, because that 6 also shouldn't be there. Y needs to be by himself. And when we divide by 6, we divide everything by 6, which is slightly different from when we're adding or subtracting. When we're adding and subtracting, we only do it one time on each side, and we line up like terms. But when we're dividing, it's like we're dividing the whole side, and that's sort of distributive property for dividing. So we end up getting 1/6 x. That's another way of writing x over 6. And then 7, because that's 42 divided by 6. Well, that's not what they asked. They wanted the slope and the y-intercept. So there's the slope, and there's the y-intercept, right? Boom. Okay. So just a few more. Number 26. We got parallel as a concept. And parallel means that you have, this is the point that they gave you, but parallel means that it has the same slope. And their equation, so theirs, is y equal to 2x minus 6. So if I can look at this and go, hey, this is slope-intercept form, right? That means that he's their slope, m is equal to 2. Well, that means that ours is the same thing, m is equal to 2. That's what it means to be parallel. So now I have a slope and a point, and I can use the point slope form, y minus y1, which is 2. If you want to label, you can, x1, y1, equal to slope, parentheses, x minus 3. Now they want it in point slope form. That's what they asked for, so we're done. I love that. But you got to be, you have to read the instructions to see what they want. Do they want point slope form? Do they want slope intercept form? If I remember correctly, when I wrote the quiz, I decided that I wanted most of those equations to be in slope intercept form. And that's because if you're given more than one point, your point slope forms can look different. And, slope intercept form only has one look. 27. Another point slope form one, but he's giving you 4, 5. And he's telling you with their equation, it's y equal to 4x plus 7. And it's perpendicular. So this is parallel. That means that the slopes are the same. Their slope is 4. When they want perpendicular, they want you to do something different. It's not the same slope, it's the exact opposite slope. So with 4, we want to think of that as 4 over 1, because when we find a perpendicular slope, we have to do two things. One, flip it. So now it's 1/4. And the second thing is you want to change its sign. So it was positive, and that means that ours is negative. Okay, so flip it, change the sign. That gives you your perpendicular slope. All right, so now we have our point and our slope, and we just write our formula. Y minus x1, y1, 5 equal to negative 1/4, the slope, and then x minus 4. And it wants point slope form, so we're all done with that. Lovely. All right. 28 asks you to do slope-intercept form. So that little extra bit after you do point slope is what they want. 5, 3 is the point they give you. Their equation is y equal to 1/7 x plus 5. That means that their slope is 1/7. And they want perpendicular again. Perpendicular. So we want to flip it, change the sign, right? So 7 over 1, and now it's negative. Negative 7. Let me write that better. There we go. Okay, so point slope form, y minus x1, y1. 3 equal to negative 7, parentheses, x minus 5. Point slope. But they don't want that. They want slope intercept. So we're going to go distribute. Plus 35, because two negatives make a positive. And then we want to add 3 to both sides. And again, adding, subtracting, we do it 1 on each side. So we end up with negative 7x plus 38. And this is probably, seeing me do this extra bit will help you more on the quiz than the point slope form questions on this practice sheet. So yeah, pay attention to number 28. Pay attention to, where else did I do it? Nope. Pay attention to number 16. That's a big one. They'll help the most with your quiz questions for that week. All right, 29 and 30 are the last two questions, and they're asking you to find a rate of change. Now, rate of change is definitionally, for us, equal to the slope. Well, hey, I know how to find the slope. I know how to find the rate of change then. But here is the thing. They have f of x and that's equal to the square root of 2x, right? So this is another way of saying y equal to the square root of 2x as a function. Now this isn't a line, this is a curve. And we haven't talked about graphing curves, but the idea is that what we want to do is for the x1 is 2 and x2 is 8, that's what they give us. We want to find the y1 that goes with 2, and we want to find the y2 that goes with 8 by plugging it into this formula. So square root of 2 times 2 is the square root of 4, which is 2. Does that make sense? Did I just ask a question to an audience who I don't hear? Yeah, I did. Isolation is getting to me too. 2 times 8, plugging in 8, we get 16. The square root of 16 is 4. So now I have my x1, my x2, I got my y1, and I got my y2. And slope has a formula, y2 minus y1 over x2 minus x1. So we got y2, which is 4, y1, which is 2, x2, which is 8, x1, which is 2. And that means it's 2 over 6. And that reduces to 1 over 3. And that's the answer. Right? Not so bad. So with rate of change, it's like a slope problem, only they're asking you to find some y values first, y1 and y2, before you can apply the slope formula. So same deal here, f of x equal to 5x plus 7. And you have x1 is equal to -1 and x2 is equal to 0. So we're going to plug in -1 into my x here. So y1, I'm losing it, 5 times -1 plus 7. And then 0, y2 is going to be 5 times 0 plus 7. That's -5 plus 7, that's 2. And this 0 plus 7, because anything times 0 is 0, and that's 7. So I got x1, x2, y1, y2. So my slope is, sorry, you can't see that. There we are, we're back. In case you need to see that now. y2 is 7, that's first. y1 is 2, that's next. And then x2 is first on the bottom, and then minus -1. So we got a minus thing going on. 7 minus 2 is 5. 0 plus 1 is 1. So my rate of change is 5. Oop. I hope you guys, that helped for week 2, I believe. I didn't do a week 1 one yet because that was kind of review of stuff we went over before spring break. If you need a week 1 video for doing those worksheets, I can put that up, but I'm going to do week 3 and week 4 first because that's where we're at right now, okay? Thanks for coming in. Thanks for checking in. Bye.